Finally, if you're in the standard form, then you're solving this equation, right? That equation is really easy to solve. All you do is subtract k from both sides, divide both sides by a, and you get this. I'm not going to go through those steps. If you've got to see it, look at the video. Okay? But I think everybody in here should know how to do that. And if you don't, again, look back at the MCR video or look carefully at the steps I've written out here. Now, the one thing that you've got to be aware of, and where I see people making mistakes that I wish they wouldn't, is when you solve something like this. Now remember that x squared equals c has two solutions if c is positive. Okay? Well, it has two solutions either way, but the solutions are imaginary if c is negative, right? The only way it doesn't have two solutions would be if c is 0, because then the only choice would be x equals 0. Okay? X squared equals c, though, in general, is equivalent to saying that x equals c or negative c.
Square root.
Okay, like x squared equals 25. Well, sir, x could be 5. Everybody wants to take the square root of both sides, so you get square root of negative k over a, or you'd get 5, but you forget about the negative 5. Negative 5 is a perfectly good solution to x squared equals 25. Plug in negative 5, and you do, when you square it, you do get 25, right? So that is a solution. So you got two solutions. And you got to be aware that there are cases like with absolute values and with equations like this where you split into two solutions. And the one we just saw where we factored the quadratic and got two different factors, we split into two solutions, okay? And all those things are related, but I'm not going to worry about the relationship. So x minus h squared equals negative k over a solves as x minus h equals plus or minus the square root of negative k over a, right? Now you add h to both sides, you get x equals h plus or minus the square root of negative k over a. Okay? Now, negative k over a could be positive, it could be negative, or k could be 0, and it would be 0, right? Okay? You get two real solutions if negative k over a is positive, because if negative k over a is positive, then the square root is a real number, and you have h plus or minus that real number. You get one repeated root if k equals 0, and we'll see soon why you call it a repeated root, okay, when we get into polynomials. And you get two complex conjugate solutions if negative k over a is less than 0. So you have the same situation you do if you use a quadratic formula. And in fact, if you did the distributive law to expand this and bring all your terms together, you can put this into general form and use the quadratic formula. But it's easier to do this because this is really easy. You just subtract this from both sides, divide by this, and solve it. Okay? Just a few steps, and the numbers tend to be easier to evaluate. So it'd be cause for joy if you had to solve this one.